All right, welcome back, everyone, to Artificial Intelligence, Unorthodox Lessons, the show where we try to demystify some of the more, well, unorthodox aspects of AI.
And a huge thanks to Notion Wave for making this deep dive possible. Their work in AI is pretty mind-blowing, especially in research and education and, well, pretty much everywhere else.
Yeah, Notion Wave, they're really pushing the boundaries. So today, we're going to dig deep into the nitty-gritty of building real-world ML products, stuff that you don't always learn in a textbook.
Right, the kind of things you pick up when you're, actually in the trenches.
Exactly. And we have a really fascinating story to unpack today. One of our listeners, who happens to be a machine learning expert, shared their experiences from building a gesture control armband at a wearable tech company.
Oh, wow, an armband that responds to your gestures. That sounds like straight-up sci-fi.
Yeah, it's definitely a cool piece of technology, but what's even cooler are the challenges they face bringing it to life, the mistakes they made, and what they learned along the way. We're going to break down 4 key mistakes their team encountered, mistakes that are surprisingly common when translating ML theory into a tangible product.
Right, because it's always different in practice, isn't it?
Absolutely. So our goal today is to learn from their missteps so you can avoid similar pitfalls in your own AI ventures. Whether you're building a startup, leading a tech team, or just curious about the real-world side of ML, there's something here for you. So let's jump right in. The first mistake they highlighted was this idea of the single end-to-end model.
Yeah, I can see how that would be tempting, right? You think, okay, if I could just build one supermodel that can recognize any gesture from anyone, that's it, game over.
Right, you'd have this sort of universal gesture translator.
Exactly, but as you can imagine, things didn't quite work out that way.
So what happened? What made this seemingly straightforward idea so difficult to achieve in practice?
Well, the team quickly ran into a wall, and that wall was human variation. It turned out that people are far more different from each other than they initially anticipated, and these differences had a huge impact on how the armband recognized gestures.
So it wasn't enough to just have a massive data set of gestures. The model also needed to account for all the subtle ways people are different.
Exactly. They found that muscle anatomy, skin conductivity, even perspiration rates, all these things varied significantly from person to person.
Wow, so even things like sweat could throw off the readings.
Yeah, apparently it affects the electrical signals picked up by the sensors.
Yeah.
And then there were more obvious differences like forearm circumference. But one of the biggest challenges was the sheer variation in how people perform the same gesture. Like what you might consider a fist could be slightly different from what I consider a fist.
Right, so it's not like there's one universal fist gesture that everyone makes in exactly the same way.
Nope, and that really threw a wrench in the works for the single model approach.
So how did they try to address this issue of human variability?
Well, their first thought was to segment the users. They figured, okay, maybe one model can't handle everyone, but maybe we can create different models for different groups of people.
So sort of like personalized models based on certain characteristics?
Exactly. They started with forearm circumference, because that was easy to measure, and they saw some improvement in accuracy.
So it was working.
To a degree, yeah.
But then they ran into a new problem, user experience. Imagine having to tell the armband your forearm size every time you wanted to use it, or having to switch between different model profiles. It just wasn't very user-friendly.
Yeah, that would get old pretty fast.
Right, so they were kind of stuck between a rock and a hard place. They could have accurate models that were inconvenient to use, or a less accurate but more user-friendly single model.
So what did they end up doing?
They came up with a clever solution. They decided to offer users 2 options. The first was a population model, which was trained on data from their entire user base. This model was designed to work reasonably well for most people right out of the box. So like a general purpose model that's pretty good for everyone.
Exactly. And then they also offered a personalized model option. This allowed users to train a model specifically for themselves using their own data.
Oh, that's neat. So if you were willing to put in a bit of effort, you could have a model that was tailored to your unique physiology and your way of making gestures.
Exactly. It was a smart way to balance the need for accuracy with the desire for a smooth user experience.
This really highlights an important point. When you're building ML products, you have to think about the trade-offs between broad applicability and personalized performance. It's rarely a one-size-fits-all situation.
Agreed. Sometimes you need to give users options so they can choose the approach that works best for them.
Okay, so moving on to the second mistake. This one revolves around the importance of a properly collected test data set.
Ah, yes, this is crucial. You can't just blindly collect data and expect it to accurately reflect the real world.
Right, because if your test data doesn't match the real world, your evaluation metrics are going to be misleading.
Exactly. And this is especially challenging when you're dealing with a brand new product
How so? Why is it harder to collect representative data for a new product?
because you don't fully understand your users yet.
Yeah.
You don't know exactly how they'll use the product, where they'll use it, who the primary users will be, all those things.
So you're essentially trying to predict the unpredictable.
Pretty much, yeah. And in the case of the gesture control armband, they ran into this problem head on. They knew that certain factors, like forearm size and skin condition, significantly impacted the accuracy of the model.
So how did they try to account for these factors in their test data?
Well, forearm size was relatively easy. They could just measure a bunch of people and make sure their test data had a similar distribution of sizes.
That makes sense. But what about skin condition?
That was trickier. They conducted smaller studies to understand how skin condition affected the readings, but they couldn't replicate that level of detail at scale for their main test dataset.
So their test data was representative in terms of forearm size, but potentially skewed in terms of skin condition.
Exactly. And that meant they couldn't be 100% confident in their evaluation metrics.
Right, because even if a model performed well on the test data, it might not perform as well in the real world where there's a wider range of skin conditions.
Exactly. And that's a really important takeaway for anyone building ML products. You always have to be critical of your test data and ask yourself, does this truly reflect the diversity of my users and the conditions they'll be using the product in?
It's not enough to just have a lot of data. The data has to be the right data.
Absolutely. It's about quality over quantity.
All right, on to mistake number 3. This one has to do with the limitations of relying solely on standard performance metrics.
Ah, yes, the classic metrics like accuracy, precision, and recall.
Hmm.
They're useful, but they don't always tell the whole story.
Especially when you're dealing with a complex ML product that has multiple potential outcomes, right?
Exactly. The gesture armband is a perfect example. It was designed to recognize 5 different gestures.
So you have 5 different things the model needs to correctly identify.
Right. And if you try to evaluate each gesture using those 3 standard metrics, you end up with 15 different numbers to juggle.
That's a lot of numbers, but even then, it doesn't tell you everything you need to know, does it?
Nope. Because not all errors are created equal. A false positive for one gesture might be a minor annoyance, while a false positive for another gesture could be a major problem.
Can you give us an example?
Sure. Let's say the model mistakenly recognizes a random hand movement as a fist. If the user was trying to pause a video with a fist gesture, it's not a big deal.
Right, just a bit of inconvenience.
But what if that same false positive triggers an emergency call in a different app? It's a whole different ballgame.
Suddenly, a seemingly minor error becomes a potentially serious issue.
Exactly. And that's why relying solely on those standard metrics can be misleading. They don't take into account the real-world consequences of different types of errors.
So what's the solution? How do you make sure you're evaluating your model in a way that reflects its real-world impact?
You need to define problem-specific metrics, metrics that are tailored to your product's use cases and that consider the relative importance of different types of errors.
So instead of just looking at overall accuracy, you need to dig deeper and understand the specific ways your model can go wrong and what the consequences of those errors would be.
Precisely. It's about understanding how your model's performance translates into user experience.
This is a great point for our listeners to think about. Are you relying too heavily on those standard metrics? Have you really thought about the real-world implications of different types of errors in your application?
It's a question worth asking yourself. It can make a big difference in how you develop and evaluate your models.
Okay, let's tackle the 4th and final mistake. This one's about the often misunderstood relationship between more data and better models.
Ah, yes, the classic misconception that more data automatically equals better performance.
Right, the just throw more data at it approach.
It's tempting, but it's not always the answer. Sometimes more data leads to diminishing returns, and in some cases, it can even make your model worse.
So if more data isn't always the solution, what is?
The key is to prioritize model archiving. You need to systematically store your models along with all the relevant data, like performance metrics, hyperparameters, and the datasets used for training and testing.
So it's not just about having the latest and greatest model. It's about keeping a history of your model development process.
Exactly. This allows you to compare different models over time, go back to older models if they happen to be better suited for a new task, and generally just have a better understanding of how your models are evolving.
That makes a lot of sense. You're essentially creating a library of your ML knowledge.
Right, a knowledge base that you can tap into whenever you need it.
You mentioned a hypothetical scenario where having a model archive would have been incredibly useful. Could you walk us through that again?
Sure. Imagine you've been working on a model that's really good at minimizing false positives for a specific gesture.
So it's really good at not triggering the gesture accidentally.
Right. But then a new use case emerges where false negatives for that same gesture become a bigger problem.
So now it's more important that the model doesn't miss the gesture when it actually happened.
Exactly. And if you have a well-organized model archive, you can go back and find an older model that might be better at minimizing false negatives, even if it wasn't the absolute best at minimizing false positives.
So you don't have to start from scratch. You can leverage your past work.
Exactly. It can save you a lot of time and effort. But this kind of efficient retrieval and comparison isn't possible if your models and data are scattered all over the place. You need a proper artifact management system.
So it's not enough to just dump everything in a cloud storage bucket.
Nope, you need a system that allows you to search, filter, and compare your models based on their performance and other metadata.
This is another great takeaway for our listeners. Are you archiving your ML models and their associated data? How easily can you find and compare past models based on specific criteria? If you're not doing this, it's definitely worth considering.
It's an investment that will pay off in the long run.
All right, so we've covered a lot of ground today. We've learned about the myth of the single end-to-end model, the importance of a representative test data set, the limitations of standard performance metrics, and the need for proper model archiving.
It's a lot to digest, but these are really important lessons for anyone who wants to build successful ML products.
Absolutely. Real-world ML development is full of nuances and challenges that you don't always learn about in theory.
It's a constant learning process.
So, to recap, here are the 4 key takeaways from our deep dive today. Don't assume that a single model will solve every problem. Be prepared to explore more tailored or personalized approaches. Critically evaluate your test data and make sure it truly represents your users and the conditions they'll be using the product in. Go beyond standard metrics and develop problem-specific measures that reflect the real-world impact of your model's performance. And finally, build a robust library of your ML models and their associated data so you can leverage your past work and adapt to new challenges.
Those are some golden nuggets of wisdom right there.
We hope this deep dive has been helpful in giving you some things to think about as you navigate the exciting world of AI product development.
Yeah, keep those lessons in mind and you'll be well on your way to building some truly amazing things.
And if you're hungry for more insights into the unorthodox side of AI, make sure to follow our podcast, Artificial Intelligence, Unorthodox Lessons, wherever you get your podcasts.
We'll be back soon with more deep dives into the fascinating and sometimes confusing world of AI.
Until then, keep learning, keep experimenting, and keep pushing the boundaries of what's possible.
And remember, sometimes the most valuable lessons come from the mistakes we make along the way.
Thanks for joining us, and we'll see you next time.
See you then.